Okay, so here are the strategies that we have available to us when we are stuck with 0 over 0. The first one is factor and cancel. So if you are, I'm going to kind of point to this example down here. If you are looking at polynomial over a polynomial, it's definitely a reasonable thing to see if you can factor and cancel. So if the top or the bottom factors and you can cancel out a factor, that may very well help you be able to evaluate the limit. So if f is a rational function and direct substitution of the limiting x value creates 0 over 0, remember when we were first reviewing this, what we were talking about 0 over 0 can be in a graph. Remember, it's not an asymptote, it's a hole. And so in these cases, if possible, factor and cancel any common factors. Then try direct sub again. Okay, so factor, cancel, and then sub. So remember, anytime you're approaching a limit like this, the first thing you want to try to do is direct sub. When we do that, well, I can definitely see that 0 in the denominator. And the numerator will give me a positive 9 minus a 3, which is 6, minus a 6, which is also a 0. So there is that direct sub 0 over 0. Always your first strategy is direct sub, but this doesn't tell me anything. So I'm going to keep my limit notation in front. Notice that what I'm going to be doing when I factor is not actually evaluating the limit. I'm not plugging anything in. So I need to keep my limit in front. I don't remove this limit as x approaches -3 until I apply the limit laws, which means until I directly sub. So it's going to be important that you get your limit notation correct and that you keep your limit in front of every step until you actually do the substitution. So I'm going to factor the numerator. That's a pretty straightforward factoring problem. I'm going to cancel the common factor. So now I just have the limit as x approaches -3 of x minus 2. And I'm going to try direct sub again. So at this moment, when I substitute in the -3, that's when the limit notation goes away because I am actually evaluating the limit now by plugging in. And that will give me a -5. So what this is telling me is I have this function, which really simplifies to this function every place except for at this x is -3. And when x is -3, there's a hole at -3, -5. That's the location of the hole. Okay, so you might want to just put a little note to yourself about keeping limit notation until I sub in, which is here. Okay, to make sure that you're following those rules correctly. That is, in fact, what I've put inside this important yellow box. You must make sure you have that in front. We've talked about this already in a previous lesson, but I just want to make sure you remember this. We've talked about the function x squared plus x minus 6 over x plus 3. If you are to write that it equals x minus 2, and that's it, that is not true because these are not equal at that point. X is -3. These two functions are equal to each other everywhere except here because this function does not have -3 in the denominator. So you have to make sure that their limits are the same, and it's okay for you to cancel them out and keep the limit notation in front. But if you cancel like this in the red without limits in front and without that disclaimer, then you've written something that is incorrect. Okay, so just be sure that you are paying attention to notation. It really does matter. Okay, strategy number 2 is multiplying by conjugate. So this one looks a little funky when I try to explain it. So I think it might even be easier to just show you, but let's first just make sure we outline what a conjugate is. Okay, it's where you have the same terms, but you switch the sign between them. Okay. So for example, if you start with A plus B, its conjugate is A minus B. Or if you started with A minus B, its conjugate is A plus B. And the reason we do this specific multiplication is because it's a difference of squares. And in cases where we have square roots, it will eliminate a square root. And that's really what's very helpful. Okay. So I'm going to go jump to the example here. Let's work through that, and then we'll go backward to the kind of outlining the strategy. All right, so as usual, I'm going to try direct sub. Square root of 0 plus 1 minus 1 over 0, which gives me 0 over 0. So there we are in the familiar 0 over 0 situation. All of these strategies that we're talking about right now are meant for 0 over 0 situations, but I just want to make sure you are getting in the practice that that's where you always want to start, is direct sub. Okay, so I can't factor this. So strategy 1 is out. Hence why we have this other strategy. So you'll notice that on the top, I have a square root of x plus 1 and then minus 1. So this is like my A minus B. So it's a little bit small. I'm just going to start with this piece right down here. I'm just going to write the original problem I have. There's my A minus B. So I'm going to multiply that by A plus B. So I'm just switching the sign in between. But I can't just multiply the top by something. In order to keep it equal, I have to multiply top and bottom by the same thing. So I'm really multiplying by a 1, not changing its value. All right, what do we have to keep in front of the next step? We have not evaluated the limit yet. We're just doing some manipulation. So we have to leave that limit notation in front. Now, I could multiply this all out, FOIL it all out on top. But remember, we've talked about this is what we have. So A squared would just be x plus 1. And B squared would just be 1. So we're using that handy algebra pattern to just multiply that out more easily. These denominators are going to be kind of gross. Don't distribute. Leave them in this product form. It's going to be easier to evaluate in the end. All right, if I simplify on the top, x plus 1 minus 1 is just x. Still need my limit in front. I'm not plugging anything in yet. And here is a great example of why we left this denominator factored, because now I have an x on top and an x on bottom, and that x, those x's can cancel. So simplifying one more time here, I now have 1 over the square root of x plus 1 plus 1. and I'm going to try direct sub again. So as I go to plug this 0 in for the x, that is when I can leave my limit notation out, because now I am applying the laws and saying that the limit is equal to this number, which gives me 1/2. Okay, so this is the process. I just want to go back and try to explain it to myself. What am I doing here? How to use this? So what we basically did is we multiplied the top and the bottom, it's got to be both, by the conjugate of whichever one was the sum or possibly the difference. One of them will be a sum or a difference, so then you can give it a conjugate. We multiplied out the conjugate pairs. In fact, we did that using this formula up here, which made it simpler. But leave the other part alone. You don't want to multiply it out. It's going to be better if you don't. You might end up having something that will cancel. So simplify and then try direct sub again. Okay. So sometimes I think it's a little easier if we try an example first, and then kind of go back and try to explain what we did. Okay. And we have one more strategy that we want to talk about, which is that sometimes your 0 over 0, it could be dealt with by simplification. Maybe you have a complex fraction that can be simplified if you can get it down to a more simple fraction. Or perhaps, like in the example below, you can't really apply the limit laws here because you end up with a number over 0 for both of these, which means neither of these limits exist. So is there a way that we could simplify this first? And that is definitely a strategy that we want to use. So I'm just going to add here, simplify the function to have one numerator I can't spell numerator and one denominator. Then apply the appropriate strategy. And that will be for either b over 0 or 0 over 0, depending on what you have. So there are a lot of different examples of this. We just have one here. But if I were to try to sub in directly with the 0, I would have 1 over 0 plus 5 over 0. And remember, the limit laws said that we can only apply like the limit of one plus the limit of the other if both of those limits exist, and neither of those limits will exist. So this is not an effective way for us to attempt this limit. So what we're going to do is just take this inside function and try to rewrite it as one fraction. So I need to actually add the 1 over x plus the 5 over x times x minus 5. So you need a common denominator, right? They both have an x already, so it looks like x times x minus 5 would work, which means we just need to multiply this first one by x minus 5 on top and bottom. Okay. And then if we add in the numerator, we see that the 5's cancel. And now I have rewritten this in terms of one numerator and one denominator, which means when I go to do the limit, I can now cancel and then apply direct substitution. So the limit does in fact exist. And we figure that out by rewriting what we're taking the limit of as one single fraction first, and then applying direct substitution.